Okay, so now let's solve a problem for an RC circuit, a circuit that involves a resistor and a capacitor. So this is the problem. We have a capacitor that is already charged, okay? This capacitor is already charged. The capacitance of this capacitor is 35 microfarad, and we are going to connect it to this resistor that has resistance 120 ohms. Okay, we want to know how much time will elapse, how much time will it take for the voltage to drop, for the voltage to fall to 10% of its original value. They didn't give us this original value. They say that this original value is just V naught. We want to know how long it takes. So what is the time that it takes for this potential difference to drop, to become 10% of the original? In other words, to become 0.1 times that original value. Okay. So what is the story? Well, first we have to remember what is the equation involved here. Remember, once we put a capacitor connected to a resistance, it was going to discharge. It's going to discharge really rapidly according to this equation. V is equal to V naught exponential minus T over RC. Okay, so this is the equation that we talked about in the previous lecture. Okay, that's the equation that we need to solve this problem. What is going to be the potential difference? 10% of the original. So I'm going to use this equation, 10% of the original. Okay, that's what I have on the left side. On the right side, I have that V naught. So they didn't give us this V naught, but it doesn't matter because it will cancel. I have it on the left and I have it on the right. What is my unknown? The time. So exponential to minus this time. I'm going to put the time in red because this is my unknown. Divided by RC. Well, what is RC? We have that. We have that R is 120 ohms. We have that C is 35 microfarad. So we can obtain what this RC is. So R is 120 multiplied by 35 to the power 10 to minus 6. If you do this calculation, you're going to get this result here, 4.2 10 to minus 3. Okay, so I'm going to put this in my equation. Okay, so I have here 0.1 V naught equals to V naught exponential of minus the unknown, which is T, divided by this number that we got there, 4.2 multiplied by 10 to minus 3. Okay, let's cancel now this V naught. We said is the same on the left, on the right. How do we get the time now? Well, we have an equation that is involving an exponential. To get rid of this exponential, we do a ln. Okay, the ln of an exponential to a certain power is whatever I have in that power. Okay, so this is what I'm going to use. So let me rewrite our equation here. I'm going to do the ln. Okay, so let me just rewrite the equation. Exponential to minus t divided by that 4.2 10 to minus 3 equals to 0.1. I'm going to do the ln on the left and I'm going to do the ln on the right. So ln of this whole thing, exponential of minus t 4.2 10 to minus 3, and on the right ln of 0.1. So this is a number that you can get from your calculator. On the left, ln of the exponential just gives what we have on top. So minus t divided by 4.2 10 to minus 3 equals to ln of 0.1. Everything here are numbers now. Put in your calculator and you get a number for this. So you will have minus t is equal to 4.2 10 to minus 3. You have this number and you have the number that you got by ln of 0.1 and you are going to get the time. This ln of 0.1 is a negative value. You will see in your calculator. So you have negative value here, negative here. It will cancel, and we will give you as we want, as expected, that the time is positive. If you would get a time that is negative, it would make no sense. You're going to get a time that is positive, which is 9.7 10 to minus 3 seconds. So double check that you get this value, so then everything is correct. And this is the end of the problem.